Welcome, everybody, as we dive into composing functions by using ordered pairs. Our objective for today is be able to compose functions using ordered pairs. Now, at the moment, I'm like, well, that's just circular logic right there. We're just saying the same thing we just said. Make sure you say this in your audio part of your Edpuzzle. Well, let's look at a couple diagrams. So if we read them, given two functions f and g, where x is the domain of g and g of x is the domain of f, then f of g, x of x, is equal to f of g of x and g of f. Okay, well, all this is doing is making me seem like, hey, this looks like a smile right there. It's making me look like a clown right now. I'm feeling like a clown. I'm just like saying a whole bunch of things, and it makes it seem like it's kind of hard to understand. But wait, maybe we can draw a simpler diagram. So pretty much what we're doing is we're going to have a rule. So our rule could be, hey, I want you to, no matter what, whatever number you put in, you're going to times 2. So whatever x is, you're going to times it by 2. That could be the first rule. So let's plug in a couple things. Let's plug in -3. Let's plug in 0. And let's plug in 10. If we plug these in first with the -3, out will pop out the following numbers. 2 times -3 is -6. If we plug in the next one, 0 times 2 is 0. And if we plugged in 10, 2 times 10 is 20. Well, that's pretty good. We're good with that. But what we're talking about right now is we're talking about we have a machine inside the machine. Our next rule, we could say, hey, no matter what we input, we're going to subtract by 2. So immediately after these numbers went into the first machine and came out, they're going to go straight into the second machine, and out's going to pop out some new numbers. So if we plugged in -6 minus 2 would be -8. And if we plugged in 0, 0 minus 2 is -2. And if we plugged in 20, 20 minus 2 is 18. So if we're looking at this, we're going to have this is pretty much g of f of x. So we're plugging in here, and we're plugging in different things. We're pretty much plugging one in the other. But we could also do it the opposite way. Subtract by 2 and then times 2. That would give us something totally different. So let's do an example and show you what happens. But first, I want to point out this part right here. I want you to think, how can you say this in 10 words or less? There's going to be a question on Edpuzzle. Let's go on in 3, 2, 1. So, example, we're actually going to do the ordered pairs. The rule within the rule, that's tomorrow's lesson. That's future use problem. The rule we're doing now is we're going to take these and we're just going to, hey, we already have our inputs and our outputs. We don't need to know the rule. So we are going to find both the function of g, f of g, and g of x. All right, well, we're pretty much going to take each of the g answers right here. So you might want to we might want to do it right now. So if we have g of 4 and g of 5, and g of 13 and g of 12. Here's our side work right now. We're doing our side work. Well, if we plugged in 4, our output is going to be 1. And if we plug in 5, our output is 0. And if we plugged in 13, our output is 9. Hey, what if we plugged in 12? What should we get? All right, we're going to get 10. So now that we know if we plugged in these, what we would get, we can take these values and plug it into the other machine. So let's try that out. We have f of g of 4 right there. And that's going to equal f of 1, which is, if we plugged in 1, we get 12. And then if we do f of g of 5 right there, that's f of 0. And what happens if we plugged in 0? We get 13. And if we plug f of g of 13 right here, we should get f of 9, also known as 7. And finally, if we plugged in 10, because that's what we're going to get when we do g of 12, we should get 11. So what we're going to do is now we're going to pause it for a second, and we're going to go down, and it looks like there's enough room. So we'll write it right here. We're going to find the domain and the range. Now, the domain is everything we inputted. So if we look at this, I can write out our domains as 4, 5, 13, and 12. But we're going to put it in order. So the domain will equal the set of numbers of 4. And so it's these numbers right here, guys. What did we input at the very beginning? 4, 5, 12, and 13. You might be like, hey, wait a second. That's not the order we did. We're putting it in numerical order, okay, guys? Now, the range is going to be our final output. What did we finally get out? Well, I got 12, 13, 7, and 11. Well, put it in order. 7, 11, 12, and 13. And so that's this final part right here. Turns out we didn't really need all that space. And that's okay. Now, we're going to do the same thing, g of f. Now, the only thing different that we're seeing right here is we're going to see that, hey, you might mix these up. You might think, hey, which one do we do first? And if you look at this, hey, do it in order of, like this is saying, hey, I want to do this rule onto this guy. So you do this guy, and then you do whatever this guy has right here. So it's kind of like out of order a little bit. So I'm going to write this down. I'm going to write down all the F inputs we're going to do. So I'm going to pause it, and then I'm going to play it afterwards. Actually, go ahead and you try to write down the inputs and outputs of F. All right, so our inputs are 1, 10, 0, 9. So right now, I know my domain are going to be everything inside this first function, everything I inputted first. At least I think it is. Now we're going to take these and we're going to input them back in. So I'm going to input whatever I got for the range of the f right here. I'm going to input that in right now. F of 1 is equal to, and why don't I write this all out and then we can go on. All right, so this is what we get. G of 12. If I input 12, I'm going to get 10. If I input 11, hey, wait a second. There's no input 11. So I'm going to put this right here. If I input 13, I'm going to get 9. And if I input 7, wait, there's no input of 7. So because 11 and 7 are not in the domain of G, so G, the domain of G, does not have 7 or 11, G of f is, undefined for when x is 11 and x is 7. Now, this might be the case where, hey, this is where we have that limit where it's like, hey, I'm not touching. But like, you're like, hey, I inputted something and I think it should work, but it doesn't because it says, hey, it's not there. So we can't use it. So for this, we really only have two answers right here. So like G of f right here will equal just 1, 10, and 0, 9. And that's okay. So we can talk about the domain. The domain of this one, there's only 2 values that will work right here. So the domain for this is not all 4. The domain will equal the subset of 0 and 1. And the range for this one is only 2 numbers as well. It will be 9 and 10. So the domain is everything we inputted, and the range is our final output. And in this situation, there's 2 values that have no outputs. So if it has no outputs, it's not a number that would work. So we're not going to say, hey, the domain is 10 if it doesn't have an output at the very end, because it doesn't have an output. Every domain needs an output. Well, not really, but like for it to be a proper ordered pair. All right, guys. Thanks very much, and I'll see you in class. Bye.